Today we'll be talking about the product case study, the external hard drive. This is it assembled, and this is the component breakdown and the components of interest. First, the spacer ring. It's used to separate two discs from touching while attached to the spindle motor. The ring was probably produced through the lathe machining as evidenced by ridges on the surface. In order for the spacer and the spindle motor to fit together and operate without interference, they must be machined to fit within the cylindrical tolerance zone. The inner diameter of the ring is 0.7865 inches and the outer diameter of the spindle motor is 0.786 inches. Therefore, the gap should be 0.0005 inches, or else there is a higher likelihood of interference.
This is the top cap. It is placed at the top of the mechanism to hold the discs in place. We believe this part was stamped out of steel sheet metal because of the uniform thickness. A small indent on one side of the piece suggests it might have been pushed with an ejector pin. Pictured here are the magnetic heads. There are 4 on the arm, 1 for each side of the 2 discs, which help with reading and writing. These parts were probably manufactured by laser etching due to the high level of detail required. This part is the head arm, and it controls the radial position of the magnetic heads on the discs. The shape is unique, and we believe it was made with CNC milling due to visible machining tool marks on the side. Alternatively, this part could potentially have been manufactured using die casting, which would have increased production rate but lowered the level of control on the surface tolerance zone.
The base casting looks to have been casted. It has a parting line, which shows that a flash was there previously. It also has ribs that prevent warping of a casted part. The part was end milled in places where parts were mounted. The workpiece shows backstriking as shown by double feed marks made by the trailing edge of a mill cutter. The screw threads were probably cut with a lathe because they are pretty sharp to the touch. The screws could alternatively have been thread rolled, but this is improbable because the threads would feel dull to the touch. The ribbon circuit is produced by laminating copper with extruded polymer sheets. In the chemical blanking that follows, a laser activates light-sensitive fluid on the sheet surface and hardens the fluid. The sheets are acid washed, thereby removing the unhardened fluid and copper layer underneath it. This is the only process that can yield the precise circuit needed.
The image below shows the actuator coil within the hard drive. It was concluded that the actuator coil was gas metal arc welded because oxidizers in the electrodes can prevent oxidation, which makes it possible to weld multiple layers within small thicknesses. It's simple, versatile, low temperature, and an economical welding process, which is favorable for automated electronic components. This image is of the spindle motor of the hard drive. The most probable type of manufacturing process for the spindle motor would be lathing. We can determine this by the high level of repeatability in the manufacturing of the spindle motor. This can only be conducted through the use of a CNC or computer numerically controlled device. The enclosure was most likely produced using extrusion because the sides of the enclosure were not containing any material. If there was the same material as the body, we could tell that the process used was milling. Extrusion is more probable when compared to milling because of its economic advantage. Molding is not considered because the material used in aluminum and not thermosets